Matter, as we just studied, is made up of particles, and these particles are extremely tiny in size. What else can we learn about matter? Assume we have a classroom full of tiny tots. We can fill one classroom with kids so that they have enough leg space and space for movement, but not enough to run and play about like that on a playground. However, due to a small crisis, the students from the other class had to be shifted to this room. Do you think the room can accommodate more kids? Yes, surely it can. They would be cramped, but they can definitely be accommodated. That's exactly how matter works. The particles in matter have space in between them. So particles of one type of matter get into spaces between particles of the other. We saw that in our earlier example of dissolving salt in water. Now, when you shift students from one class to the new one, do you think the teacher has to push each one and find them a place to sit? No, they themselves move and find a place for themselves. They have energy to walk and move about. Similarly, particles of matter move about with their own accord. They are continuously moving. They have kinetic energy stored in them to help them move about. Let us look at our students again. If one student spots a box of chocolates, won't they all crowd around it? And what if one spots a rat under a desk? They will all disperse and maybe even run out of the classroom. Well, particles of matter also get attracted to some other particles, while at times they are repelled and disperse. These forces actually decide on the state of the resultant shape of the matter. And how exactly does force do that? If all the particles are strongly attracted to each other, there will be very little space between the particles. The resultant state of the matter will be that of a solid. What if the particles are a little far apart? The resultant state will be that of a liquid. And assume the particles are very far away from each other. There is a lot of space to be filled in. What state would the matter be in then? It will be in a gaseous state. Particles that are very close to each other are attracted by a huge force which keeps them bound tight. Particles in a liquid are held by a little lesser force, while particles of a gas are free. Can we interchange these states of matter? Can we get a particle of gas to become a particle of liquid? You must watch our next video to know the answer. See you there.